Hello class, this is part 2 of the counter sequence design. The next thing we need to do is create the truth tables for our JK flip-flops. Now you could proceed to develop these truth tables directly into the K-map. However, for clarity purposes, I like to develop my truth tables first before I create my K-maps. But once you become more experienced, then you can directly map the next state truth table into the K-map, and you can skip this step number 3. So we need truth tables that will output the correct values to the value of J and K for the flip-flop. So let me quickly draw a flip-flop with J and K inputs and the Q outputs that are available for each flip-flop. This will help make it clear what we're trying to accomplish. We're trying to find out what values should be at J and K in order to create the proper value of Q, or the proper transition of Q from an old value to a new value based on this table here. So I will need a truth table for each J and K flip-flop. So here I will start with my inputs, which is the present state of my flip-flop for each step. And since I have 2 flip-flops, I'll need a J and K for each one. So there's the J and K for the first flip-flop. And here's the J and K for the second flip-flop. Probably easier if I just erase. This is live video and I'm not editing right now, so I will make a few mistakes. Later, as I become more proficient and have more time, I will edit these mistakes out. But for now, I just want you to have what you need to prepare yourself for the exam. Alright, I will change a little bit of color here so that I can distinguish between the J and the K for each output. Alright, now I'm ready to start using the next state table to help me decide what value should be in J and K. Now to make this easier, I need what they call a transition table. And a transition table tells me what values of J and K I need in order to make a transition from 0 to 0 or 0 to 1 and so on. So I will pause here so I can get the transition table ready for us. Okay, I am back and I will paste the transition table into the screen. Now, this table will be given to you on the exam, which shows you what values of J and K that you need in order to transition for the 4 possible options between the Q in the present state and the Q that we want for the next state. Alright, let us begin. Okay. Now we're at 0, 0 and we're going to transition to a 1, 0. So let's start with Q1. Q1 goes from a 0 to a 1. In order for that to happen, we look at our transition table. The value of J must be 1, and we don't really care what the value of K is, so we leave it as an X. So we should plot 1X for J and K. Now for Q0, it goes from a 0 to a 0. So it doesn't really change. So in order to meet that requirement, J must be 0 and X must be 0. Sorry, don't care. So what we have done is we have put the proper values of J and K for each flip-flop that needs to be available when the next clock pulse arrives, so that it will transition from this state to this state for both flip-flops. Now I will continue without making any comments, and you can just follow along. Now I'm on the last transition, 1 1 to 0 0. Since they're both transitioning from 1 to 0, I will just copy paste. Right, so this is my truth table that I will use to develop my final Boolean expression for my J and K. So I will stop here and start the next video for the mapping and the development of the Boolean expression.